Alright, so a hypothesis test for a large sample binomial. So let's say there are 100 MCQs in a paper, and the probability of getting the answer right to one question is 0.25. Now, let's say a student gets 34 right answers. And now we have to test at a 5% significance level. So a significance level of 5%. We have to test whether the student was guessing or not. So if he was guessing, he should get 25 answers right, but he has 34 right answers. That means there is a chance that he was not guessing. So first we will declare our null and alternate hypothesis. So our null hypothesis will be that the probability of getting an answer right is 0.25, and the alternative hypothesis is going to be probability greater than 0.25, that the student is not guessing the answers. He actually knows the answers to some questions. So then we will set up the binomial. So the binomial is going to be x follows a binomial with n equals to 100 and probability of success equals to 0.25. Now the observed value over here is 34, and the rule for carrying out a hypothesis test for a binomial was observed or a probability of observed or extreme value. So this will become probability of x greater than equals to 34. So this means we have to calculate the probabilities of 34, 35, 36 all the way to 100, and then we'll compare it to our significance level. But the problem here is that our n is pretty big. It's 100. So what we will do here now is we will approximate it to a normal distribution, because np is greater than 5 and nq is greater than 5. So the both conditions meet, and np greater than 5 and q greater than 5. So since both since we meet both conditions, so we will approximate it to a normal distribution. So this will become x follows a normal. The mu, that is np, will be 2500 into 0.25, and variance is going to be 18.75. Now, probability of x greater than equals to 34. This can also be written as probability of x greater than 33. So after continuity correction, this will become probability of x greater than 33.5. Now this becomes probability of z greater than 1.963. This turns out to be 1 minus probability of z less than 1.963, and this is 0.0248. Now you compare it to your significance level. So the calculated probability is 0.0248, and your significance level is 0.05. So clearly your calculated probability is less than your significance level, and when that's the case, you reject null hypothesis. That means we have evidence to conclude that the student was not guessing the answers. In fact, he knew some of his stuff. So this is how you carry out a hypothesis test for a large sample binomial. You set up the parameters, you set up the binomial, you set up the probability that you need to calculate, then you approximate it to a normal distribution. Why? Because your n is large. N in this case was 100, so we approximated our x to a normal, with mu being 25 and variance being 18.75. Then we did continuity correction because we are moving from a binomial to a normal, that is a discrete distribution, to a continuous distribution. And then you just calculate the probability. You compare your probability to your significance level. If the calculated probability is greater than your significance level, you accept null hypothesis. If it's less than your significance level, you reject null hypothesis, like we did in this example. So that's about it for a hypothesis test for a large sample binomial.